Hey guys, today we're going to be dividing polynomials, and to do that we're going to use long division. So let's go ahead and remember what long division is by dividing 591,808 by 56 using long division. So remember, when we're doing long division, we set it up like this. So we'll have 56, and then underneath our long division sign we will have 591,808. So the first thing we do is look at how many times 56 goes into 59. Well, 56 goes into 59 one time, so we write a 1 above the 9. And then you multiply 1 times 56, that gives you 56. And you write that below the 59. Now you subtract that 56 from the 59, and you're left with a 3. And you bring that 1 down. Now you find out how many times 56 goes into 31. Well, 56 doesn't go into 31 at all, so you write a 0 in the next spot. And then you do 0 times 56, which is 0. 31 minus 0 is 31. Bring down the 8. So now we're going to look at how many times 56 goes into 318. And that is 5 times. So we're at 5 in the next spot, right above the 8. And then you do 5 times 56, which is 280. Write that below the 318. Subtract. And you will get 38. So again, we have to bring down the next digit, which is 0. So we have to bring down the 0. So we have 380. So we look at how many times 56 goes into 380. So just 380 divided by 56. And it gives you 6.78-ish. So since we're looking at how many times it goes into it cleanly, it's just 6. So you write a 6 above the 0. And then do 6 times 56. And that gives you 336. Do your subtraction again. And we get 44. Bring down the 8. And now we have to look at how many times 56 goes into 448. And that is 8 times. And since 8 times 56 is 448, we're left with a remainder of 0. So 591,808 divided by 56 is 10,568. So when we're working with long division and polynomials, we'll have a little bit of vocab, and we have the dividend, the divisor, and the quotient. Remember that we take the dividend and we divide it by the divisor, and we get the quotient as our answer. And then whatever is left over is our remainder. So that is a little bit of vocab that we're going to have to need. So to do this long division, the first thing we will do is arrange the terms of both the dividend and the divisor in descending powers of any variable. So that's like x to the power of 4 plus x squared plus x, something like that. Then you're going to divide the first term of in the dividend by the first term of the divisor. And the result is the first term of the quotient. Then you multiply every term of the divisor by the first term of the quotient and write the resulting product beneath the dividend like the terms lined up. Then you subtract the product from the dividend and bring down the next term in the original dividend and write it next to the remainder to form a new dividend. So this is pretty much just like what we just did in the bell ringer, except we're going to be using polynomials. And number 6 is use this new expression as a dividend to repeat the process until the remainder can no longer be divided. This will occur when the degree of the remainder, the highest exponent on the variable in the remainder, is less than the degree of the divisor. Alright, so let's get an example on how to actually do this. So we're going to use long division to find the quotient and the remainder when x squared plus 14x plus 45 is divided by x plus 9. So we have our x plus 9, and we have x squared plus 14x plus 45. So we're doing x squared plus 14x plus 45 divided by x squared plus 9. So our first thing we're going to do is we're going to look at this x squared and we're going to divide it by the x. Well, x squared divided by x is just x. So we write an x above the 14x. Then you multiply x by x plus 9. And that gives us x squared plus 9x. And then we're going to subtract that from the two terms above it. So we have 14x minus 9x, that is 5x. And then the x squared minus the x squared, nothing, so it cancels out. Now we bring the 45 down, so we have a plus 45. And now we look at what 5x divided by x is. Well, 5x divided by x is 5, so we write plus 5 above the 45. Then multiply 5 by x plus 9, which is 5x plus 45. Subtract them, and we'll be left with a remainder of 0. So, x squared plus 14x plus 45 divided by x plus 9 is equal to x plus 5. So let's go ahead and do another one together. We're going to use long division to find the quotient remainder when x squared plus 10x plus 21 is divided by x plus 3. So we have x squared plus 10x plus 21 divided by x plus 3. First thing we do is x squared divided by x, which is just x. So we write that x above the 10x. Then do x times x plus 3, which is x squared plus 3x. We're going to subtract those. 10x minus 3x is 7x. The x squared minus x squared is gone. Bring down our 21. So we have plus 21. Now we look at 7x divided by x, which is 7. So we write plus 7 here above the 21. Do 7 times x plus 3, which is 7x plus 21. Subtract them, and you will get a remainder of 0. So x squared plus 10x plus 21 divided by x plus 3 is equal to x plus 7. So now we're going to divide 4 minus 5x minus x squared plus 6x cubed by 3x minus 2. Now in this one, the first thing I need to do is write each of these expressions in descending order, so my highest exponent down. So my 4 minus 5x minus x squared plus 6x cubed, that's out of order, so I'll rewrite it as 6x cubed minus x squared minus 5x plus 4. And I'm going to divide that by 3x minus 2. Okay, so we'll do 6x cubed divided by 3x, which is 2x. So I write that I'm sorry, 2x squared. So I write that above the x squared. So I have 2x squared. Multiply 2x squared by 3x minus 2, and I will get 6x squared, cubed rather, 6x cubed, minus 2x squared. I'm sorry, 4x squared. Subtract that. So negative x squared minus negative 4x squared. That'll give me a positive 3x squared. And 6x cubed minus 6x cubed, they will cancel out. So I have to bring down my negative 5x. Now I look at 3x squared divided by the 3x, which is just x, so I put plus x above my 5x. Multiply x by 3x minus 2, I get 3x squared minus 2x. And I'm going to subtract that. Negative 5x minus negative 2x is negative 3x. And my 3x squareds will cancel out. Bring down the 4, and I get plus 4. So now I look at negative 3x divided by 3x. Negative 3x divided by 3x is negative 1. So I write the negative 1 above the 4. Multiply that negative 1 by 3x minus 2, and I get negative 3x plus 2. And I'm going to subtract that. Then I have 4 minus 2, which is 2. And then the 3x's will cancel out. Now, in this case, we do not get 0 in this very last part, so that means we have a remainder. So, my answer right now so far, we have our answer as 2x squared plus x minus 1. And if we were to keep going, we would take this 2 and divide it by the 3x and keep going on. But since we were out of stuff in our dividend, we will just leave it as plus 2 over our divisor 3x minus 2. So your final answer is 2x squared plus x minus 1 plus 2 over 3x minus 2. Alright, so go ahead, do this one by yourselves. Remember to get it in the correct order first and then start your long division. So go ahead and pause the video, and when you're ready to get the solution, unpause it. So when we work all this out, we will get our final answer as 2x squared plus 3x minus 2 plus 1 over x minus 3. So now we have 6x to the fourth plus 5x cubed plus 3x minus 5 divided by 3x squared minus 2x. So in this case, we'll take 6x to the power 4 plus 5x cubed. And since there is no x squared term, we're going to write it as plus 0x squared because we still need something in that spot. And then we'll just finish it up. And we're going to divide this by 3x squared minus 2x. And that's the only thing different about this one. So you just follow out the same algorithm. So go ahead, pause the video, work out the rest of the problem, and when you're ready for the answer, unpause the video. So when you get to this point, we will have everything we need in the top. So we'll have our quotient, the 2x squared plus 3x minus 2, but we still have this 7x minus 5 to take care of. And that is our remainder, so we write it just like we were writing the other remainders. So our solution is 2x squared plus 3x plus 2 plus 7x minus 5 over 3x squared minus 2x. So that is our solution. Alright, so go ahead and do this next one by yourselves. When you're ready for the solution, go ahead and unpause it. Again, you're going to have to use a spacer for the x squared part. That way you have something in that spot, so just use the 0x squared. Go ahead and pause the video. When you're ready for the solution, unpause it. So your final answer for this one will be 2x squared plus 7x plus 14 plus the remainder of 21x minus 10 over x squared minus 2x. So we can also divide polynomials using what we call synthetic division. But we can only use synthetic division whenever whatever we're dividing by, our divisor, has an x value with a coefficient of 1. So such as this x plus 2 here, that only has the x only has a coefficient of 1, so we can use synthetic division. So we find the 0 of that, so x plus 2 equal to 0. So the 0 is x equals negative 2. And we will use that in our synthetic division. Now notice in this 5x cubed plus 6x plus 8, there is no x squared, so we'll use a 0x squared. So to set up our synthetic division, we put our 0 in the upper left hand corner, and then we write out the coefficients of our dividend. So we had a 5, then a 0 from our 0x squared, then the 6, then the 8. And we wrote them out all right here. So the first thing we do is bring down the 5 right here. Bring down the 5. Then we multiply negative 2 times 5, and then we write that below the 0. So negative 2 times 5 is negative 10. Then we do 0 minus 10, and that gives us a negative 10. You write that below it right here. Then we're going to multiply negative 2 by negative 10, and that gives us a positive 20. So then we add 6 plus 20, that gives us 26. And we keep going through the same algorithm. I'm sorry, I skipped a step. In step 3. I forgot to tell you that we add them right here. Anyway, so we keep following the same algorithm. So we're going to take negative 2 times 26. That gives us the negative 52 right here. Add 8 and negative 52. And we get negative 44. So we were out of room on our synthetic division table. So that means our final answer is going to have a remainder. So we will take this row right here, and that is our answer. And our answer is always 1 degree below our original dividend. So our answer is going to be 5x squared minus 10x plus 26 minus 44 over x plus 2. So that is our solution. So let's go ahead and do another one of those together. We're going to take x cubed plus 5x plus 5 and divide it by x minus 3. So we're going to take x minus 3 and find our 0. And that gives us x equals 3. So that means in my synthetic division, I will have a 3 in the upper left-hand corner. Then I write out my coefficients from the highest degree to the lowest. X cubed has a coefficient of 1, so I write a 1. 5x has a coefficient of 5, so I write a 5. Then, I'm sorry, I skipped the x squared. We have to write a 0 in for the x, 0x squared. So here's our x cubed. This is our x squared. Now we're on our x, which is the 5. Now we're on our constants, which is another 5. So now I can go ahead and start my synthetic division. First thing I need to do is bring down the 1. And I'm going to multiply 3 times 1, which is 3. Then I add 0 and 3, which is 3. Then I do 3 times 3, which is my 9, right that below the 5. 9 and 5 is 14. So then I do 3 times 14, which gives me 42. 5 and 42 is 47. So I will use these as my coefficients, starting with x squared. So I have x squared plus 3x plus 14, and then remainder of 47 over my original divisor, x minus 3, as my solution. So now we're dividing x cubed minus 7x minus 65 by x plus 2. We're going to do this synthetically again. So I start with my 0, x plus 2 equals 0, so x is equal to negative 2. So I have negative 2 in my upper left-hand corner. Then I write out my coefficients. X cubed, coefficient of 1. X squared has a coefficient of 0, so 0. The x has a coefficient of negative 7. And then my constant, negative 6. First step is to bring the 1 down. 1 times negative 2 is negative 2. 0 plus negative 2, negative 2. Multiply negative 2 by negative 2 gives me a 4. Add negative 7, 4, which is 3. Negative 3, rather. Negative 2 times negative 3 is 6. Add them. I'm sorry, this should be 65. My bad. Negative 2 times 6 is, negative 65 plus 6 is negative 59. And then this will be my remainder. Write out my solution. Start with the x squared. So the coefficient of the x squared is 1. So I have x squared minus 2x minus 3 with a remainder of minus 59 over x plus 2 as my solution. So with polynomial division, we have the remainder theorem. And the remainder theorem says if the polynomial f of x is divided by x minus c, then the remainder is f of c. So if we're looking at x cubed minus 4x plus 5x plus 3, we'll be able to find the remainder by finding f of 2. So we find f of 2, so that'll be 2 to the power of 3 minus 4 times 2 squared plus 5 times 2 plus 3. This will tell us the remainder if we were dividing by x minus 2. So when we work all that out, we will get 5. So if I would divide x cubed minus 4x squared plus 5x plus 3 by x minus 2, I would get a remainder of 5. So let's go ahead and check that. So if I was working with x minus 2, my 0 would be 2. Then I write out my coefficients. So 1, negative 4, 5, 3. Bring down my 1. 2 times 1 is 2. And then I'll have a negative 2. Negative 2 times 2 is 4. 4 plus 5 is, it'll be negative 4. 5 plus negative 4 is 1. Then I have a 1 times a 2, which gives me a 2. 3 plus 2 is 5, so I will have a remainder of 5, which is what our remainder theorem predicted. So if we were given that 3x cubed plus 4x squared minus 5x plus 3, we are going to find the remainder theorem. Use the remainder theorem to find f of negative 4. So that's as if we were dividing by x plus 4, because if we set that equal to 0, you get x equals negative 4. So we'll find out what the remainder is if we divide it by x plus 4. So we'll do that by finding f of negative 4, which would look like 3 times negative 4 to the power of 3 plus 4 times negative 4 squared minus 5 times negative 4 plus 3. And when we would work all that out, you would get negative 105. So that would be your remainder by using the remainder theorem. You also have the factor theorem. The factor theorem says if f of x is a polynomial, we have f of c equal to 0, then x minus c is a factor of f of x. And if x minus c is a factor, then we know that f of c is equal to 0. So if we want to solve the equation 2x cubed minus 3x squared minus 11x plus 6 equal to 0, given that 3 is a 0, then that means since this 3 is a 0, we know that x minus 3 is a factor of the polynomial. And if we divide 2x cubed minus 3x squared minus 11x plus 6 by x minus 3, we will get another expression. We will a factor. We will find a 0. So let's go ahead and divide the 2x cubed minus 3x squared minus 11x plus 6 by x minus 3. So using synthetic division, we'll have 3 in the upper left-hand corner. Then we have 2, negative 3, negative 11, and a 6. Bring down my 2. 2 times 3 is 6. Add those, I get negative 3. 3 times negative 3 is negative 9. And I'm sorry, this is a positive 3 here. Making that a positive 9. Then negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. And a remainder of 0 again. So that means when I divided, I got 2x squared plus 3x minus 2. So if I multiply that by what we said earlier, the x minus 3, I will get my original function. And now we can find the other zeros by factoring that. We're going to save that for later, but we can factor that and then be able to use that to find my other zeros. So if we want to solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, and we're given that negative 1 is already a 0, we will divide our original polynomial by x plus 1, and since x plus 1 is my factor, I know that I will have a negative 1 in my top left-hand corner. So I'll write out my coefficients, 15, 14, negative 3, and negative 2. Bring down our 15. I'll get negative 15 here. And then a 1. Negative 1, actually. Negative 1 times negative 1 is a 1. Negative 3 plus 1 is negative 2. Negative 1 times negative 2 is a positive 2. And again, I have my remainder of 0. So I know that our original function is equal to x plus 1 times 15 x squared minus x minus 2. And then from that, again, I'll be able to find my zeros. So that finishes up today's lessons. We will work on the homework tomorrow, both homeworks tomorrow in class. I'll explain it when we get there. So enjoy the rest of your day and take it easy, guys.